day everyone, I am Raymart Guzman from BSA 3B Mathematics. Welcome to our new session of Teaching Mathematics. Our new lesson for today is all about Wilson's Theorem. This theorem was proposed by John Wilson and published by Waring 1770. Although it was previously known to Leibniz, it was proved by Lagrange in 1773. So, in Wilson's theorem, it states that if p minus 1 factorial divided by p, or what should I say, mod p, then it equals to negative 1 mod p, or simply equals to remainder p minus 1. So let me give you a basic example. Let's say for example, our prime or p is 7, then it becomes mod 7. Then it becomes 6 factorial equals negative 1 mod 7. So, why it become like this? Because p or 7 minus 1 factorial is 6 factorial. Then, mod, our prime number is 7 equals negative 1 mod 7. So, how can we get the 6 factorial? We should have to multiply 6 by 5, by 4, by 3, by 2, and by 1. So, the 6 factorial is equal to 720 mod 7 equals equals 102 mod or remainder 6. So, when we apply this to negative 1 mod p, it becomes negative 1 mod 7 or 7 minus 1 equals 6. So, the answer are both 6. They are the same. So, this is the basic theorem in Wilson's theorem. So, let us proceed to our next example. But this time, let's try to upgrade the given. Let's say, (11 factorial mod 13. Then it becomes 12 factorial it becomes 12 factorial mod 13 equals negative 1 mod 13. So, again, our prime is 13 minus 1, it equals to 12 factorial mod our prime again is 13 equals negative 1 mod 13. So, again, we just have to get the 12 factorial. And that such are 12 times 11 times 10 times 9 and etc. But this time, we have to stop in 11 factorial. Why 11 factorial? Because our given is 11 factorial mod 13. So, it becomes 12 times 11 factorial mod 13 equals negative 1 mod 13. So, the next step is to eliminate the constant here in left side. So, here is the trick. How many 12 is mod 13? And that is 12. Still 12. But, we can use negative 1 here for us to eliminate the constant in the left side. So, it becomes it becomes negative 1 times 11 factorial mod 13 equals negative 1 mod 13. So to eliminate negative 1, we have to divide negative 1 by negative 1. Then it becomes 11 factorial mod 13 equals 1 mod 13. Why it become 1? Because negative 1 divided by negative 1 is equal to 1. Meaning, our 11 factorial mod 13 is equal to 1 mod 13. And the remainder is positive 1. Let's proceed to our third and last example. Let's say 20 factorial mod 23. So again, 23 minus 1 is factorial is equal to 22 factorial mod 23 equals negative 1 mod 23. So the factorial of 22 is 22 times 21 times 20, etc. But again, we have to stop in 20 because our given is 20 factorial mod 23. So, it becomes 22 times 21 times 20 factorial mod 23 equals negative 1 mod 23. Again, we have to eliminate the constant in the left side, which is 22 and 21. So, to eliminate that, we have to subtract 22 by 23. Then it becomes negative 1 times negative 2 times 20 factorial mod 23 minus 1 mod 23. So, it becomes negative 1 times negative 2 times 20 factorial mod 23 equals negative 1 mod 23. So, we can eliminate negative 1 in the left side by dividing negative 1 by negative 1. Then it becomes negative 2 times 20 factorial mod 23 equals 1 mod 23. So again, it becomes positive 1 because negative 1 divided by negative 1 is equal to positive 1. But how can we eliminate negative 2? We can eliminate that by simply 1 minus 23. Then it becomes negative 2 times 20 factorial mod 23 equals negative 22 mod 23. So, why it become like this? Because negative 22 is divisible by negative 2. Then, we can divide negative 22 by 2. And we will have a answer. Then, it becomes 20 factorial mod 23 equals 11 mod 23. So, why it become 11? Again, we divided negative 22 by negative 2 and that is positive 11. Meaning, 20 mod 23, 20 factorial mod 23 is equal to 11 mod 23. And our remainder is 11. So that's it for this session. I hope you enjoyed and learned from this video. Keep safe and God bless. Thank you for watching.